Our topic in MATHG10 in second quarter for week 2, graphing a polynomial function. So we have here the question, what is the destiny of my behavior? Given the polynomial functions y equals open quantity x plus 4 closed quantity, then open quantity x plus 2, then closed quantity, then open quantity x minus 1, then closed quantity, then we have open quantity x minus 3, then closed quantity. Then we have here the table. Answer the question that follows. Okay, we have the first column, so that is the value of x. And the second column, that is the value of y. Then for the value of x in the first column, we have negative 5, negative 4, negative 3, then negative 2, then 0. Then we have 1, 2, 3, and 4. Then for the value of y, so we have 144. That is an ordered pair, negative 5 and positive 144. Then the relation of y value to 0. Okay, so we have y is equal to 0, or we have y is less than 0. Then next is y is greater than 0, then y is equal to 0. Then the last column, that is the location of the point, that is x and y. In the first term stands for the x-axis, and we have the second term stands for the y-axis. So we have the above axis, and we have also on the axis the x-axis. So at what point does the graph pass through the x-axis? What can you say about the graph? This table may be transformed also the simpler one, that is instantly help you in locating the curve. Then we call this the table of sign. So we have the table of sign. Sketch of the graph of this function can now be constructed. And then we have the table of sign, that is the test value, x plus 4, x plus 2, then x minus 1, then x minus 3. And then we have x is less than negative 4. Then we have negative 4 is less than x is less than negative 2, that is the interval. And then we have the position of the curve related to the y-axis. Then we have the graph of the y is equal to open quantity x plus 4, then closed quantity. Then we have here x positive 2, then closed quantity, then open quantity x negative 1, then closed quantity, and x minus 1, x minus 3, then closed quantity. Then we can now use the information from the table of sign to construct a possible graph of the function. So at this level, we cannot determine the turning points of the graph. Then we can only be certain that the graph is correct with respect to interval where the graph is above, then below, or we have the x-axis. Then we have here the graph. To describe, to interpret or describe this graph, the arrowhead at both ends of the graph signify that the graph definitely goes upward. Then we have here another example. So you are going to sketch the graph of f of x is equal to negative x of x positive 2. Then we have open quantity 3x minus 4, then close quantity. The roots of f of x, negative 2, 0, and 4 over 3. Then we have the table sign, then the intervals. The table sign or the test value, x negative x positive 2, then 3x negative 4. Then we have here x is less than to negative 2, negative 3 positive, negative positive. Then we have negative 2 is less than 0, that is negative 1, positive, negative. Then we have here the graph. Then how can you interpret this graph? This is now the graph of the polynomial function. Then the graph is form a curved line. Then you learn how to sketch the graph of polynomial functions using the intercept, some points, and the position of the curve determined from the table of signs. The procedures described are applicable when the polynomial function is in factored form. Otherwise, you need to express first a polynomial in factored form. Okay, so we have another example, that is, for each of the following functions, give the x-intercept, the interval obtained when the x-intercept are used to partition the number line, the table of sign, and the sketch of the graph. Okay, then the activity the activity 9. Then all you have to do, just follow the path. After sketching manually the graph of the 5 functions given in activity 8, you will now be shown polynomial functions and their corresponding graphs. Study each figure and answer the questions that follow. Then summarize your answers using the table similar to one provided. Then we have the case 1 and case 2. For the case 1, the graph on the right is defined by y is equal to 2x squared negative 7x squared negative 7x then positive 12. Or in the factor form, y is equal to open quantity 2x plus 3 then close quantity, and we have open quantity x minus 1 close quantity, and then we have x minus 4 then close quantity. Then you have to answer the question for the case 1. Is the leading coefficient a positive or negative number? Then for letter B, is the polynomial of the even degree or odd degree? Then for letter C, observe the end behaviors of the graph on both sides. Is it rising or falling to the left or to the right? Then for the case 2, the graph on the right is defined by y is equal to x raised to the power of 5, positive 3x to the 4th power, positive x cubed, negative 7x squared, positive 4. or in the factor form, that is y is equal to negative open quantity x positive squared. Then we have x negative 1 and x negative 2. Then you have to answer the questions in case 2. Is the leading coefficient positive or negative? Is the polynomial of even degree or odd degree? Observe the end behaviors of the graph on both sides. Is it rising or falling to the left or to the right?